Hey everyone, welcome to another video lesson for Unit 12.3. So this is just more laws of exponents. Zero exponents means that you have any variable or number to zero power that's always going to be equal to 1. So number 1, x to 0 power is 1. What about number 2? Well, the 0 applies to the to x and also to the 5. So even though you multiply 2 times 0, that still becomes 0. So you have x to the 0 and 5 to the 0, which ends up being 1 times 1, which is equal to 1, right? What about number 3? This is to the 0 power. This is x to the first. So then this becomes x to the 0 power, which is 1, times x to the first power, which is just x. So that's the answer to this one, okay? Next, the quotient rule. So with the quotient rule, when you divide powers, you actually subtract them, as long as you have the same base. So for example, this is x to the fourth over x to the first. All we do is we subtract the powers, right? So for this one here, this is x to the fourth minus the first, which is x to the third. So that's the answer to this one. Number 2. So for number 2, we have x to the third minus the fifth, because that's x to the y to x to the fifth in the denominator. It's a negative power, times y to the third minus the first, because this is y to the first. So then this is equal to 3 minus 5 is x to the negative second power, and y to the 3 minus 1, that's y to the positive second power. Whenever you have a negative exponent, you need to make that positive. And the way you make it positive is you bring it to the denominator. So then this is equal to y to the second over x to the second. And that's the answer to this problem. Okay? All right. What about negative exponents? And I just gave you an example here. If you have a negative exponent, just bring it to the denominator, which is what happened to the negative second power. It came to the denominator. So when dividing, I have x to the negative third, and I want to make this positive, a positive exponent, and y to the fourth is positive. So then this is just y to the fourth on the numerator and x to the third in the denominator, because of that negative exponents rule. Okay. All right. Next one. This is negative. This is negative. But watch what happens here. So I'm going to explain this step by step. So for this one, I have x to the negative second power. Since this is negative here, you're actually going to subtract, right? Subtract that. Well, let me explain it differently. So what I am going to do is I'm going to rewrite this. I'm going to notice that y has a positive power for this one, right? So then to make it positive, this is negative, and I'm going to bring it to the numerator, and I'm going to bring the x to the denominator. So then we have y to the first times y to the third. Okay, because if it's negative here, then bring it up to the numerator and denominator. I have x to the third times x to the second. If it's negative in the numerator, then bring it to the denominator to make it positive. So then what happens here is I have x to the third times x to the second. Again, all we do is we add the powers. So then this is equal to y to the first times y to the third is y to the fourth over x to the fifth. And that's the answer to this problem. All right, next one. 9 over 3. That 9 becomes a 3, and this 3 becomes a 1. Then I have x to the second over x to the fifth. Again, this power is negative, so it's like saying 5 minus 2, and I need to make that 3 positive, so I bring it back down to the denominator, meaning I have x to the third, and this is y to the negative first power, but I have a y to the negative first power in the denominator, so I need to switch this too. And I don't know if you see that, I'm going to bring this to the denominator, meaning I have... let's see, so this will be y to the third, and this 3 stays in the denominator again because I have a negative, no, not the third, the second power. That was a mistake on my part. The second, right? If it's negative here, I need to bring it down to make it positive, so this actually ends up being 1 plus 1, right? To make that power positive. So that's how we ended up with y to the second power in the denominator. And that's the answer to that problem. Okay, so when multiplying, what about when you multiply? Same idea. I'm going to multiply the coefficients. So multiply 4 times 7, which gives us 28. And then we have x to the 6th minus the 4th. We end up with x to the 2nd. And notice since 6 is positive and the 4th is negative, so you're just basically subtracting 4 from 6. And that's the answer to this one. Second example, negative 3 times 8, that's negative 24. The 11th power minus the 5th power, that's x to the negative 6th power. Since the power is negative, well, I should write it down. So x to the negative 6. Since this power is negative, we need to bring that to the denominator. So then this becomes negative 24 over x to the 6th. Then now we're done with this problem. Okay. All right. Outside power is negative. So what about when the outside power is negative? So this is the power rule. So this is x to the negative 6th power, which is equal to, again, we make that power positive by applying this rule here. Okay, so I'm going to bring that to the denominator and write a 1 over it. So this is x to the 6th power. And that's the answer to this one. This one here, this is to be negative 1. So then that becomes 4 to the negative 3rd power, x to the negative 6th power, and y to the negative 3rd power. So notice they all have a negative power. So then this is 1 over 4 to the 3rd, x to the 6th, y to the 3rd. But again, 4 to the 3rd is the same as 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So then this is 1 over 64, x to the 6th, y to the 3rd. And this is our final answer for that problem. Okay. Let's see. And I forgot that 4 is negative. So then this should be negative 64. But the whole thing is negative, actually. So it's okay if you put it in front of the whole fraction or rational expression. All right. Last example. Negative 6 times 3, that's negative 18. Then I have x to the, oh, I can't do that yet, right? See, that's a mistake that I'm making because I have to apply this. You're going to make this mistake sometime, so just see if you can catch yourself right away. So I have to apply this power to 6. So I have negative, let me do the whole thing, okay? So I have negative, in this case, what I'm going to do is, notice that this power is negative outside. So I'm going to write the whole thing in the denominator. So I have negative 6, x to the 3rd, y to the 5th. Then I have 2 outside. And then since this power is negative, I'm going to make it positive by bringing this whole expression to the denominator. So I have 3x to the 4th, y to the negative 2nd power. And we multiplied that by the positive 3rd power. Okay, so then what I'm going to do next is, I'm going to take the square of negative 6. So it's negative 6 times negative 6, which is positive 36. And then 3 times 2 is 6, so x to the 6th. And then 5 times 2 is 10, so y to the 10th power. And now let's go to the denominator. So this is implied to be 1, so that's 3. The 3rd times the 1st is the 3rd. So 3 to the 3rd is 3 times 3 times 3, which is 27. And then x to the 4th, and then you're multiplying that by the 3rd, is x to the 12th power. And this is y to the negative 6, so it's negative 2 times 3. So y to the negative 6th power. So I'm going to continue simplifying by noticing that 9 goes into 36 4 times. So this becomes a 4, and 9 goes into 27 3 times. So this becomes a 3. All right, and we're almost done. We're almost done with this problem. Okay, so we have x to the 3rd to the 6 over x to the 12. This 12 is negative, so then basically what it means is that we're subtracting 6 from 12. So then we have 4 on the numerator, and then we have a negative 6 on the denominator. Let me just write this down, okay? So I have y to the 10th and y to the 6th over, I have, let's see, so on the denominator, what happens here is 12 minus 6 is 6. So then this becomes 3x to the 6th. And then I can add the powers of the y's, right? Because I have the 10th and the 6th. And when you add 10 and 6, that gives you a 16. So the numerator is 4 times y to the 16th power over 3 times x to the 6th. And this cannot be simplified or reduced any further, so this will be our final answer. So when you combine many properties together, you might get lost or confused on some steps, but you can always go back and check, okay? So just like you saw, I made a mistake, and I think I made a couple of mistakes, but you can always catch yourself. And when you do, just go back and correct it. And it's okay if you make mistakes, you know, when you're learning, even after you know, because I've been teaching this for the longest time. But, you know, sometimes the brain just throws a curveball at you, and, you know, you might write something that is incorrect, but you can always go back and check. Well, thank you for watching. I'll see you in the classroom. Bye-bye.